Last class, an age ago, in a galaxy far, far away, or at least it feels like it's been that long, you were left with the file of movement where in the draw loop it's moving a single object around based on keyboard input, so that if I press the keys, it sets left, right, up or down, true or false, so key press, key release. And then based on that information, it's modifying a rotation value for left and right, and it's modifying a velocity value based on up and down, speed up or slow down. And then when we hit the edges of the screen, it's doing some nice screen wrapping. And then we're using translate to reposition to whatever our x and y is going to be so that we can draw our object. And this is the key thing to remember. We're drawing the object effectively at 0, 0, or in this case slightly offset based on the width or size of the object. So that little tidbit of drawing the object at 0, 0 is one of the key factors to keep in mind as we built it into a class-based system. So with that, we now have the single object moving through. But if we put in multiple objects, then they're all going to be affected by these. And the goal is to put it into a class so that they are now separate. Last class we left it where we had the basic movement. You had this as your starting point. And your goal is to turn class that and then fit it into with the sprite animation as well. But that part is fairly straightforward once you have the class part broken down. So with this particular project, we can see in the draw loop, you can define a class anywhere, so it makes sense to have my main function information and then define the class after that. So we would be doing it after key pressed and key released, but I'm going to define my class in the middle here simply so that I don't have to keep scrolling up and down quite as often with it. So giving myself a little barrier so I know my class is going to be here. So if I have a vehicle class that's being defined, we know that we have our data, our constructor, and methods. So the standard 3 things that always go into every type of class, our constructor is then going to define itself out, where then we have vehicle. Vehicle will probably take some parameters. We'll figure those out as we define it. And then we have the methods that go along with it. So now we have the start of our class. Don't need the void there. So we have our class construction. We'll probably put some items in there, but we'll figure that out. Now when we're drawing the previous object, the object responded to an x and a y, had its velocities, it had all those things. So it turns out that the Booleans of left, right, up, and down correspond to the main part of the sketch because those are tied to the key pressed and key released, which shouldn't be part of the class because the key pressed and key released, that's part of the main code. That's not part of the individual object that's being created. The object is just going to have its position information and its display information. So with that, we know that we can then take some variables out. So I'm going to copy those, comment those out. Again, it's, I think, a good practice in the beginning, comment things out, don't cut them, don't delete them. Things you're no longer using, just comment them out because then it helps you to remember what it was or where it was, because sometimes you need to go back to it because you code yourself into a corner and have to find your way back out. So now our vehicle is going to have these data pieces with it. And now our constructor is where we're going to then define those, so we can go back up into the setup and see where you had your X and your Y and our R and blah, 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 all of that. And on a project like this, where if you have multiple objects and everything is being affected by a global value, like friction or like gravity, so if these are constants as part of your world that you're creating, it might make sense to define that as a constant as part of the main sketch, not as part of the object. So you could make an argument that friction really belongs here in the main setup instead of putting friction in the class itself. Or we could just put friction in the class and just do it in it. You could go either way, and you could make an argument for or against. And I'll let you decide what you want to do with that. So we can now see that at my vehicle gets its X, Y, blah, blah, blah. I think I am going to leave friction as a global because it makes sense, because friction isn't part of the vehicle, friction is part of the world, so it would make sense to have friction being defined up here, so I will leave that out. Because if I start defining 3, 4, 5, 6, 7 objects, and if each one has friction defined in it, and I decide the world needs to be a little bit slipperier, it suddenly becomes harder to define friction as it applies to that object. So I'm arguing for keeping it out. So we can now see our main setup here has our keyboard inputs, left, right, up, and down. It's tracking those Booleans, and it will have our global value of friction. The rest of the values are now going to belong to the object itself. So we have our data pieces, they've all been defined, and now it's a matter of fitting in the methods that will belong to our vehicle, utilizing the same logic that we've used before. Void update and void display. So if we keep our naming schemes consistent, if we keep our structures consistent, it does make it easier when you go from project to project to project to follow that same kind of setup. So this is now the core of a class as we've defined it. And for any class object that's going to be a visual object, you might just kind of make a file and save it out as this is a standard visual object class, where you have class, then you have class name, then you have data, constructor, the constructor information, and then you have your methods of update and display, knowing that most things that you make will follow that same structure. And if you stay reasonably consistent in what you're doing, it makes it easier as your skills grow, because you don't keep reinventing the wheel. You don't keep wondering, oh, what did I call it this time? Oh, last time it was this. It allows it to be a little bit easier to keep track of. So now the next step is with draw here. This is just filling the background with a transparent rectangle so we get that kind of fading effect. So that tells me that the rest of this information is what I'm going to need. And we can start to look at this and see it really is kind of two things. Translate, rotate, and then drawing the object. And the rest of this is all update information. So we may want to then put this information in update, this in display. So grab that out of there. Move some code over to display. Just move this up so I can get it all in one shot.
So you put it into code.
So we can see the code that is highlighted here is updating values. It's not updating anything or specifying any display command, so it would make sense to have that particular information contained inside our update function. So I'll copy that, comment out the original, move that over, and adjust things a little bit.
You got the UVX up there.
So we can see update now updates Vx and Vy based on my angle and my velocity, and then it changes the x and y based on that, and then if x and y have hit the boundaries, it kicks it over to the other side. Then we slow velocity down by friction, and then we are taking in the keyboard information, so the next update we will be able to modify x and y and velocity and blah 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 based on that information. And then if our velocity is getting too slow, we just set it to 0 so we don't end up getting a twitchy object that keeps trying to inch around or get a little bit shaky when the velocity hits very small fractional amounts. If the velocity is less than 1, it just sets the velocity to 0. And now display is going through this. So now if I run my project, we will see that I get a gray box and nothing else, which is exactly what should happen, because now that we've moved all of this code into our class, we've never bothered to call it. So now we need to call it, and we can do that. And first I'm just going to make one vehicle. So, and I will call it V. V is equal to new vehicle, and then I can each frame v.update, v.display. Now we can see it goes forward, it goes back, it rotates, and it rotates. So our vehicle is now working. Now, one word of advice: if you notice, my vehicle when it starts was pointed mostly horizontal and to the right. That is considered 0 for a rotation value. So if you construct your artwork so it's pointing horizontally right as your forward position, then when you hit the up arrow to go forward, it will actually then be going forward, leading by its head. And then we can now see then the rotation, the arrows seem to make sense based on that. Now that a single object is moving and displaying, the next activity or the trick is to not have one object but to have multiple objects. So then we do that by using our array method. So I use vehicle, and because it's faster to type, I'm just going to do cars. So it's now my cars array, and I will have max cars is my number of cars that I'm going to be working with. So I'm going to then comment out my original vehicle that I have there because I don't need that. And now we need to define it as cars equals new. And now we can define it of what type of thing again? Vehicle. HICLE. X cars. So we're defining and giving our array value. Then we need to fill our array using our for loop. And if you use tools with code completion, it does speed up what you're doing significantly on it. Oh, wrong button there. So this would put the vehicle in. Now the one challenge that I'm running into here is if I tried to run this, it would fail because max cars has not been given a value yet. So max cars, and then we can start out and say something like 10. But all 10 cars will appear at the same position on screen right now, so that's problematic. I won't actually know that I have 10 cars running. So we need to do something about that. So to get them to show up in separate locations, give them random X and Y's. And if we want them to all start with random rotations, and if we want to have them randomly rotate, theta is working in radians, 2 pi is equal to 360 degrees, or a full circle of possible angles. So we need to then say 2 times the number pi. So that gives us a range in radians of 2 pi as our value. So now we can choose, they will show up at any random value at any random position on screen. So that now gives me my vehicles appearing at random places. But at the moment, they're not going to be doing much of anything because now all of my vehicles are inside my array. One other thing is this particular line, I forgot to type the variable. We have to say v is what. The same way when we originally defined it up here, down here we have to say that we are putting a new, So to correct this line, we don't care about creating vehicle v. We want to say cars at position I is equal to a new vehicle. Apparently it's too early in the morning for me, or I did not have enough coffee for the day, or confusing too many different similar but distinctly unique programming languages in my head and forgetting little tidbits. Either way, we need to take the objects in the array as we're populating cars. We take the object at position 0, put a new vehicle in it, position 1, 2, 3, 4, until we get to our max number of cars. So when we're at position 9, it populates it, then the 10th, then I becomes 10. 10 is no longer less than max cars, so we don't get that obnoxious null pointer exception error message that happens all too frequently, and that just makes everybody grumpy. The null pointer exception or the out of bounds array message, yeah, all of those things, they're just no fun. The good part about those is they're solvable, and they're often more solvable than the out of memory error. That's just frustrating and harder to deal with and harder to ultimately solve. So this now loops through our cars, and we can use this for loop construct to now update and show our objects again. So I'm going to copy that code because then we will be calling update and display on all of those objects. So we no longer will be using those lines there, but we'll instead be saying, telling the car to update and display. So every frame will tell each car to update and display. So it goes through the first car in the array, then it's the second, the third, the fourth, the fifth, and keeps on going as it works its way through. So studying it right now, we can see we get all kinds of really interesting things occurring here. So we're having some issues with this at the moment. It's not quite working, and that falls into our display here, is translates our cumulative. So the first object we translate to its x and y coordinates. The next object translates from that x and y to the x and y of the next object, which translates to that x and y of the next object. So I have 10 objects, and every translation shifted my registration point a little bit further away from my starting point. And then when I rotate, it's rotating around that point. So yeah, it's a complete disaster. So we need each object to kind of work independently. And we can do that, well, missed, using push matrix and pop matrix. So I'm going to indent some code here just so it's clear. So when I push the matrix, then I'm doing all of this, and then I pop matrix to say I'm done doing that. That will allow each object to translate itself to its own personal set of x and y positioning. And this concept of saving your transformation information so that you can then not affect other objects is a common technique in a lot of languages. The term we may use will vary. It may be context save, context restore. In this case, we're using push matrix, pop matrix. But the concept of having to store our original location before we then do a transformation so we can undo that kind of translocation activity so that one object doesn't affect something else is a very common activity. Otherwise, we would have to store a lot more complex mathematical information for all of our objects. Now, if we run this now, you should see they all show up on screen. They're all rotating now and flying around independently. The next trick would be then working with the images and doing it with the sprite class, combining that into here, and then remembering that when you choose to draw your image, so if this were an image item, normally with image we say image and then we say the file we're trying to draw, and then we provide in an x coordinate and a y coordinate. Well, the common sense thing would be to use x and y, but because we've translated to x and y, we need to remember that we draw effectively at 0, 0. And then that will give you the correct location. Now, that's drawn at the top left corner of your image. So if you want to not have it rotate around the top left corner, but to rotate around the image itself, you need to offset these values by often a negative amount. So half of the image width. So it'd be negative half, and you'd have to know what that is, or you'd have to calculate that value somehow, and possibly, oh, and it's half of it. I forgot the divide by 2. So half of the image width, half of the image height. So you'd have to, and that would then move this transformation point so it's now drawing around the center of the object, rotating around the center of the object. And if you do that, now image width is not a defined value. I'm typing that in as, this is pseudocode, fake code. So if you type in negative image width, you'll get, a honking error message that will scold you and call you all kinds of bad names and make you cry and want to put your fist through your display and all that fun stuff. So don't do that, but you have to calculate what half of the image width is and then offset your position by that in a negative direction. And then your artwork can rotate around its middle. If you don't want to rotate around the middle, well, you don't need to do that, and you can just use 0, 0. So you need to put in the numbers that work for you. But in this case, this item is not doing an image because they don't have images yet in this particular example. So all we're doing is just our standard couple vehicles that are showing up on screen and creating their nice, cool-looking, fun-filled animations. The key things are using push matrix, pop matrix, so the items move independently. Then you translate and rotate, translating to the point you want to rotate around, and then you draw your image at the correct position. 0, 0 is a good starting point. And then you can offset by whatever amount to adjust it. But if you draw it X and Y, often you will be drawing your artwork off screen and doing all kinds of really silly things. So always draw it 0, 0, or by some smaller offset amount, and then you will have good performance with it. When it comes to putting sound into your project, since some of you are clamoring for, I want sound, because the silent world isn't working for you, the way that we can go about doing that is we have to use a library to help us out. One of the popular libraries is the Minimum Sound Library, and we can get to this by going to processing.org, clicking under Reference, Libraries, and then you will see, there it is. So processing.org, click on Reference, click on Libraries, and then we will use Minimum. If you find a different audio library, and there are other ones you can go find online, you're welcome to use that. So we're not using this because it's the only one, we're just using it because it is one. Now, the thing about it is it's already installed with processing. It's already one of the built-in libraries, so you don't have to install it yourself. The reason that you'd want to go to this website is so that you could understand and read through some of what it takes to work with it and find some of the code that you're working with. So here's some basic code for doing an audio player. And let's see, where's our starting line? Up here. So we create new minimum objects and work with that. And the help files that go with this aren't always the most user-friendly, but if you read through it, they can sometimes work.